And in this module, we're going to see how an ASP.NET MVC application comes to life, and how we can influence the behavior of our application using configuration files. Understanding how the application starts up and where the application retrieves configuration settings is important if you want the application to behave the way you would expect. I'll show you these configuration files, and by the end of the module, I have a couple of goals I want to achieve. The first goal is to understand the configuration system just well enough to display a message on the screen, a custom message from a configuration file. The second goal is to avoid hard-coding our dependency on an in-memory restaurant data source. We'll remove that code that we added in the last module that hard-coded a dependency and replace the code with something more flexible. Before we get started moving towards those goals, I think it's important to understand how we go from Visual Studio to delivering HTML in the browser. It all starts with the project that we're working with, ode2food.web. This web project contains files of many different types. There are configuration files, so you can see in the graphic that just appeared, there's a packages.config and there's a web.config. We'll talk more about those configuration files here in a bit. But there's also .cs files, so files containing C# source code. That code needs to be compiled before we can do anything interesting with that code on .NET. And there's also many other different types of files. So there are script files inside of the scripts folder. Those files can be JavaScript that we want to execute on our site. They could also be JavaScript libraries like jQuery. There's also going to be images and CSS style sheets and even CSS frameworks like Bootstrap. And anytime we do a build in Visual Studio understands how to compile these files and work everything together and place everything into a directory where my project can execute as a web application. So the primary output of ode2food.web is going to be an assembly named ode2food.web.dll. That's just a convention where the name of the assembly will be the same as the project, but it will have that DLL extension that is so common in Windows. So this file contains executable code. Well, technically, it contains code that has been compiled from C# code and is now in the Microsoft Intermediate Language format. But that is executable code because .NET, the runtime, understands how to execute and process MSIL, Microsoft Intermediate Language. But this file has no capability of starting on its own and then listening for socket connections that contain HTTP requests from a web browser. That requires some web server infrastructure. So anytime I tell Visual Studio to run my project, Visual Studio has to produce this DLL if it doesn't already exist, and then start up a web server that will host this DLL and map incoming HTTP requests and send them along to this DLL. So the web server that Visual Studio will use is either IIS or IIS Express. IIS stands for Internet Information Services. This is the web server that is provided by Windows and Windows Server. You can install IIS as a component whenever you install Windows Server or Windows, but you can also rely on IIS Express, which is a slightly lighter weight version of IIS installed for you by Visual Studio so that you can host and run web applications and at least serve up requests that are coming from the local machine. And this is what happens when I tell Visual Studio to run my application, either with the debugger or without the debugger. By default, Visual Studio will be loading my assembly into IIS Express, and then I will have the ability to point a browser to my localhost IIS Express and make a request to my application that retrieves some HTML. Or in the situations where I'm building an API, perhaps I'm fetching JSON or XML instead of HTML. But it is still HTTP messaging behind the scenes. There's an HTTP request, my application produces the HTML response, and IIS provides the hosting infrastructure so that my application can execute. And if I come over here into Visual Studio, I just want to show you again, if you start without the debugger, Visual Studio will launch a browser. It's going to go to the IIS Express website where my application is running. In this case, localhost port 44388 was selected as the location for my application. And I will know if this is IIS Express just by going to the taskbar in Windows. If I come into the system tray, this is a list of all the little icons that are running in my system tray, and you should find one for IIS Express. If I right-click IIS Express, it will show me all the websites it is currently hosting. Right now there's only one, and that is my application, ode2food.web. I can click to go to either the HTTP or the HTTPS version of this application, or I could stop this site altogether. If I do that and refresh the browser, I will find that I can no longer connect to this application. So I have to get this application running again. And I can do that by coming into Visual Studio and saying that I want to start without the debugger. Again, I usually run without the debugger because anytime you start with the debugger, at some point if you stop the debugger, perhaps to rebuild an application, that's going to shut down the web server for you behind the scenes, and then you have to start everything running again. If you start without the debugger, you can make changes in Visual Studio, you can rebuild and simply come out to the web browser and just hit refresh, and anything new, any changes that you made, should be reflected in the browser's user interface. So now we know that my application produces an assembly, odefoo.web.dll. That assembly is loaded into IIS Express, or if you're in production, it's going to be loaded into IIS. And from there, we can start to process requests like this request to the home page. Because IIS is forwarding these requests, these HTTP messages to my application. But how does ASP.NET know where to go when it receives a message that wants to reach the resource /home/contact? Let's talk about that a little bit next. There's a few magic conventions that exist in .NET and ASP.NET, and once you know these conventions, they won't seem so magical anymore. But every ASP.NET application will have a file with the name global.asax. And this file really represents your application, and it's from this file where you can define what happens at application startup. First of all, I want to show you the real contents of global.asax. I'm going to right-click and I'm going to say that I want to view the markup for this file because, as we're about to discover, global.asax really does look like more of a markup file than anything else. And here is markup that is describing an application. It is our application. And this markup is saying that there is a code behind file, that is, there's some C# source code sitting behind this file, and that code is in global.asax.cs. And the most important piece here, though, is the inherits attribute, which is telling ASP.NET, it's telling the runtime, when you go to run this application, the first thing that you need to do is instantiate a class, which is the odefoo.web.mvc application class. Where is this class defined? Well, it just so happens this class will be defined in this code behind file. Now, I bring all of this up in great detail, not because you need to remember to type this every time. It's just going to be created for you when you create a new project in Visual Studio. But all you really need to remember on a day-to-day basis is that when you're working with an MVC application, when you need to look at the startup logic for your application, the file to look for is the global.asax.cs file. Inside of here, you will find one or more methods that can hook into the application lifecycle events of this HTTP application class. One of those significant events in the life of an HTTP application is when this application starts up. So what we're describing inside of the application_start method is all of the code and all of the logic that we want to execute when this application starts up. Now, I'm going to come back later in the course and describe exactly what is happening with this area registration and this filter config where we're trying to register global filters. I'm also, in this module, going to go into more details about what happens when we register routes. But for right now, I just want to show you that most of this code that is being invoked is code that exists in the app_start folder of this project. So if I open that folder, I will see there's a bundle config, a filter config, and a route config. These are all static methods that are being invoked from this application start on the HTTP application. So let's look at, for example, register bundles on the bundle config class. If I open this up, what I'm going to discover is some configuration related to the bundling of JavaScript and CSS files. We'll talk about this later in the course when we talk about client-side programming with ASP.NET MVC. But the simplified quick version is that this application is going to try to bundle and minify scripts to make files as small as possible and to have as few downloads as possible in the client's browser. And ultimately, if the browser makes a request to the root of the website and then /content/CSS, what the browser should receive is a single file, a single download that contains all the contents of bootstrap.cs plus all the contents of the site.css file. Both of those should exist in this content folder. So bundling is simply the act of taking this bootstrap.css file and the site.css file, combining them together and then trying to minify them, which you're probably aware of that term if you've done any web programming. Minification is just trying to make that download as small as possible by removing any unnecessary characters from those files. So things like unnecessary white space can be removed so that the browser receives these style sheets, the style information, as quickly as possible. And these are the types of operations that are being configured during the startup of our application. So inside of global.asax.cs, we have an application start method that will tell this bundle config class to register the bundles. And what it does is work with the ASP.NET runtime and this bundle collection class to define the bundles and the URLs that they will respond to. So responding to /content/CSS with a bundle that includes both bootstrap.cs as well as my site.css file. And that's going to happen behind the scenes. So if we go back to the browser, let's make a request for /content/CSS. And the response that eventually appears is going to contain bootstrap.css plus site.css, and it's not going to look pretty because it's been minified, which means a lot of the line breaks and white space and comments have been removed. So that bit of configuration might explain how a request to /content/CSS behaves. But again, how does a request for /home/contact behave? How does that reach a piece of C# code or a Razor view that defines the HTML that appears here? That's what we're going to look at next when we return to application start and look at our route configuration. The process of mapping an incoming URL like localhost port 44388/home/contact, mapping this to a piece of software that we have written to produce HTML is a process known as routing. So whenever we talk about routing or defining routes, we're talking about some configuration that tells ASP.NET how to find a piece of software that can respond to a given URL, like /home/contact. Or even a request to localhost some port number / that is, a request to the root of the website. ASP.NET also has to route this request to some software component that can produce the appropriate HTML response, which in our case, we wanted to show a list of all the restaurants that are in the database. In order for that to happen, we have to tell ASP.NET how to process URLs and map URLs to components that contain the C# code or the Razor code that we want to execute. And that is what happens inside of routeconfig.registerRoutes. If we open up the route config file, this contains the route config class and the static method, which is register routes. We are given from the MVC runtime an object known as the route collection. And what we want to do is add routes into that route collection that tell ASP.NET MVC what to do with a given request. This first piece of information is telling ASP.NET MVC to ignore certain types of routes. And what follows is a route template that MVC will try to use to match an incoming URL. So what this route template is saying is that if you see a URL arriving, like the URL /trace.axt, /1/2/3/4, try to take that URL and see if it matches this template. So inside of a template, anything that is inside of curly braces becomes a parameter. So that means MVC would be looking for something.axd, and indeed this URL contains a .axd. So the MVC framework would say, well, so far that part matches, and what we'll do is treat resource, we'll treat that parameter, that piece of data, as the word trace, because that's what was in this position at the URL. And then we're going to look for any additional path info. So this star is like the wildcard character when you're doing a file search. It's saying match anything, essentially. Match anything and place it into a parameter, a route parameter known as path info. And since we have the wildcard match here, /1/2/3/4, that would all go into path info. But what we're telling the MVC framework is to essentially ignore this route. Don't do anything. It turns out there's a special URL endpoint built into every ASP.NET application that allows you to retrieve special tracing information. And that route is always something.axd, and then it can contain some additional information in the URL. What's important to us in day-to-day business programming is the map route API. This is what you'll be using 99% of the time with ASP.NET MVC. This is the route template that we will be using for the majority of building our application. What we're telling the MVC framework is that here's a new route. Give it the name default, and this is the URL template for this route. So we have a placeholder for a parameter named controller, and we have a placeholder for a parameter named action, and we have a placeholder for a parameter named ID. And that means if we receive a request like /home/contact, what MVC should do is treat home as the value of the controller parameter, and it should treat contact as the value of the action parameter. And then if there is an additional piece of information here, that is a third segment in the URL, take that third segment and treat it as a parameter named ID. And this is exactly what we're trying to do with the ASP.NET MVC framework. You might remember I said that controllers are responsible for receiving some external stimulus. So controllers are responsible for receiving HTTP requests. And what we're trying to do here is we're trying to map URLs to controllers that are defined in our system. And when we say here that the controller parameter value is home, because we have the URL /home/contact, that is telling the MVC framework to go off looking for something that is named home controller. So literally this value, home, followed by the word controller, and indeed inside of our application, we do have a class that is named home controller. So a request to /home/something is going to try to reach something in this home controller. It just so happens that /home/contact, this contact is treated as an action. So the name of the action is going to be the name of the method that is invoked on this controller. So this is like saying I want to invoke on the home controller a method named contact. And indeed, if I flip over to home controller, I will see there is a contact method here. So hopefully you're starting to see how this can come together. And then there's one piece of additional information that we can include in the route, which is an ID. But it just so happens this ID is considered optional. So I do not need an ID in the URL in order to reach an action on a controller. It's strictly optional. And what is this piece that I'm looking at here? This is part of an anonymous type, which contains the defaults for this route. So essentially what this anonymous type is doing is providing the values that ASP.NET MVC can use if a value for a particular segment here is not provided by the URL. In other words, if there is no ID, that's okay because the ID is optional. What happens if there is no action? What happens if I receive a request to just /home? In that case, let's try this. If I go to just /home, I will receive the index action of the home controller. So it is the index action that is displaying our list of restaurants. And since there's also a default provided for the controller value, if I go just to the root of the website, provide no other information, I will effectively be executing the index method of the home controller. So these routing templates are how we tell the MVC framework to route a given URL to a specific piece of software that will tell the MVC framework what to do next. So we want to route into methods on our controller classes. And what happens if I want to process a URL like /greeting? Currently, if I try to go to /greeting, I will receive a 404 error from the ASP.NET MVC framework because the ASP.NET MVC framework doesn't see any component that can respond to /greeting. It's going to go looking for a greeting controller. It's not going to find one. So it just returns a 404. But what happens if we right-click on the controllers folder, say that we want to add a new controller, and I'm going to create an empty MVC5 controller. I'm going to create an empty controller and click add, and I just will call this the greeting controller. Now again, more details on controllers throughout the rest of this course. For right now, I want to add something that will give a simple response if I make a request to /greeting on this application. And the simplest possible thing I could do is just return a view from the index action. So remember this index action, it is the default action if I did not specify an action in the URL. So if my URL is only /greeting, I have a controller parameter value from the URL. I have no action. The default action will be index. Therefore, a request for /greeting should reach this index method on the greeting controller. And what do we want to do? We want to return a view. I will need to create this view because a view doesn't exist as yet. If I just right-click inside of that method, say that I want to add a view, Visual Studio can be pretty smart and say, oh, you must want to create a view named index in the appropriate location. And I will say, yes, let's do that. We're going to leave the template empty without a model. We'll talk more about what the different templates are. For right now, I'm just going to click add. I'm going to have a razor view appear where I can just say something like, hello, with an exclamation point. And now if I rebuild my project, Shift Control B, come back to the browser, refresh, to send off another request for /greeting, then I can see I've been successful. I've added a controller that can respond to /greeting. It renders a view, index.cshtml, that displays the text hello, and we've just added a little bit to our application. In addition to the configuration that you can find inside of the C# source code files, configuration files like route config and filter config and bundle config, there's also some XML-based configuration that goes into every ASP.NET and every IIS application. One of the most significant sources of XML configuration is a file known as web.config that will exist inside of your project. If we open up web.config, we're going to see a lot of settings that can influence the behavior of this application. Some of the settings that are in here are setting up binding redirects. Binding redirects are a way to tell the runtime, when you go looking for this assembly, what you should do instead is actually find this other assembly with a different version, perhaps. There's a number of these binding redirects that exist in this web.config file. For the most part, they are uninteresting to us, and we don't need to debug or troubleshoot. They're simply provided when we say File New Project inside of Visual Studio. There's also some configuration for the compilers. This section is saying that we compile .cs files with the C# compiler and .vb files with the Visual Basic compiler. We don't need to worry about this section either. There's also some sections that tell ASP.NET what the target framework should be. In this case, we're going to use the .NET framework version 4.7.2. And there's also this generic app settings, which is a section where we can place pretty much any setting that we want. And many of the settings that are already here are settings that influence specifically the ASP.NET MVC framework. So flags like unobtrusive JavaScript enabled and client validation enabled. We'll talk about those later in the course when we start talking about client-side programming. But we can also turn features of ASP.NET on and off using some special app settings that are in this file, specifically web pages, which we're not going to talk about in this course. But what I do want to do is show you how you can add your own custom app setting and use that app setting from inside the application. Because most nearly every real application is going to need some amount of configuration. You need to tell an application what database to use or what message queue to use. You need to provide the address for some other web service that the application needs to use. All of those pieces of information are likely candidates for this web.config file. And let's say that I wanted to add a new app setting. So every app setting has a key and a value. The key is what you use to identify a particular setting. So let's say that we want to use a key of message. This is where I will store a custom message that my application is going to use. So not just the text hello, which we're currently displaying in the browser. I want this value provided by the configuration file, not hard-coded into a view. So inside of the configuration file, let's say that the value should equal "have a great day." And I will save this web.config file, and let's make use of this configuration value from our greeting controller. Now what I want to do again is make use of the model view controller framework. So I want my controller to receive an incoming request, a request for /greeting, and I want my controller to render a view, but I also want my controller to build a model that will contain the information that that view needs to render. So I want to build a model that is specific to this index view for the greeting controller. It's what some people would call a view model, because it's going to be a class whose only purpose in life is to carry information from this controller into that view. Let's go into the models folder and right-click and say that we want to add a class. I will call this the greeting model or the greeting view model. Either name would be fine. I will say I do want a class. Let's click add to add this. And for right now, let's just give this view model a single property. The property will be the message to display. So again, technically, I could find that configuration value that I'm looking for in web.config. I could find and retrieve this value from inside of the code that I place into a Razor view. But ideally, if you follow the true spirit of the MVC design pattern, your view will not do any work to find or filter data. Instead, all the data that this view needs will be provided by the controller, the greeting controller. So if I save this view model, ultimately what I want to happen is that the greeting controller will build a model that is an instance of that view model. So let's instantiate a greeting view model. And yes, I do want to instantiate this. So let's use the new keyword. And let's go ahead and bring in the namespace. So control period, I need to bring in the namespace using ode-to-food.web.models. Now I can say that the model.message equals, and again, I could hard code a value, but what I want to do is pull that value out of my configuration file. All we need to do to retrieve that setting is go to a class known as the configuration manager. I do need to bring in the namespace, which is system.configuration. And the configuration manager is going to have a static property, which is the app settings property, that will give me access to all my app settings like a dictionary. So in other words, if I index into this collection using the same key that I have specified in web.config, so the key would be message, then I should be able to retrieve the value for that app setting, and that's going to be my message. I'm going to pass that model into my view. So we saw this in the previous module. I have a controller that renders a view. It passes along a model. The view it renders is in the views folder. It's in a folder that has the same name as the controller, so the greeting folder, and the file name is the same as the action name or the method name, so which is index. So we can open up index, and remember we can get to the model by using @ and then uppercase M model. That goes to the model property, and that will be dynamic by default, but we can strongly type that property using an @model directive, so @ with a lowercase m. So I want to go to ode-to-food.web.models and specify the greeting view model as the type of my model, and now I should be able to write out model.message. And we will add an exclamation point at the end. Let me save everything, do a quick build. We'll come back into the browser and refresh. And we are now displaying that bit of information that we retrieved from the configuration file. But we retrieved that value using our controller, not by going there directly from the view. And that's just to follow some of the best practices that the model view controller design pattern tried to enforce. We've now achieved the first of two goals that I mentioned at the beginning of this module. The first goal was to display a custom message that we retrieved from a configuration source in ASP.NET. Now that we know how to do this, this is going to make things a little bit easier in the future when we need to do things like configure a database connection string. But now let's try to address the second goal. The second goal was to have some more flexible code here inside of the home controller. I'm worried that we have hard-coded a dependency on the in-memory restaurant data class. I know for right now, I'm just using this class to simulate data access so that I can get some simple things done inside of the application without building out an entire database. But later, I'm going to want to switch over to using a database. And this is a somewhat common occurrence. Perhaps not this exact scenario where I'm swapping between in-memory data and a real SQL Server database, but we always have scenarios in our applications where we want to switch out one component for another. Perhaps that's to do unit testing. Perhaps it's to do integration testing. Perhaps we want to swap out a component that retrieves configuration information from a web.config file with a component that retrieves configuration information from a web service, let's say, or from a Redis cache. We always want this flexibility in our applications, and this is the type of flexibility that the dependency inversion principle can give you. If you haven't heard of the dependency inversion principle, that is the D in the solid design principles. And I'm sure you can find some courses here on Pluralsight about solid design patterns and specifically the dependency inversion principle. So I'm not going to go into a lot of details about this particular design principle. I'm just going to show you how you can invert your dependencies in ASP.NET MVC and how you can rely on dependency injection to provide your controllers with the dependencies that it needs. So instead of hard coding that I need the in-memory restaurant data here inside of my home controller, I instead want to inject something that implements iRestaurant data and simply let my home controller depend on that object that implements this interface. It's going to be given to me in the constructor. That way my home controller doesn't have to have low-level knowledge of specific components like in-memory restaurant data. I can just depend on the abstraction, which is iRestaurant data. In order to do this, I'm going to need what is commonly referred to as a container, specifically an inversion of control container. Again, this is covered in other Pluralsight courses, but an inversion of control container is something that knows how to build objects and how to analyze objects like my home controller to understand what dependencies are required. And it's the container that can figure out what to inject when I have a constructor that says, please give me something that implements iRestaurant data. And I can turn around and take whatever is given to me and assign it into this private field for iRestaurant data. So currently, if I try to do this, the MVC5 framework does not come with a container that I can configure out of the box that will just know what to do about this iRestaurant data. So now if I come to the home page of the application, instead of seeing a list of restaurants, I should receive an error. And the error that the MVC runtime is giving me is that no parameter list constructor is defined for this object, where this object specifically is that home controller. So the MVC framework is trying to activate a controller. It sees that there is no constructor that is a default constructor. That's a constructor that takes no parameters. The MVC framework has to pass something in for iRestaurant data, and it doesn't know what to do. This is what an IOC container can do. If we tell the IOC container to instantiate a home controller, and we configure the IOC container so that it knows what to do when something needs iRestaurant data, then all of this can work. I'm going to show you how we can get this to work. In order to do that, though, we're going to need a third-party component. There are many NuGet packages out there and open source libraries that provide inversion of control containers. Just a few off the top of my head would be Ninject, Structure Map, and the one I'm going to show you, which is AutoFac. AutoFac is available as a NuGet package that I can download and install into this project, and then I can start using it. So let's get that step out of the way first. I'm going to right-click on References and say that I want to manage NuGet packages for this particular project. And I'm going to do a search for AutoFac, and I'm going to make sure that I have the Browse tab installed when I do that search. And I can see the main AutoFac package here, which is currently version 4.9.2. But I'm going to look for an even more specific AutoFac package, which is the autofac.mvc5 package. So this not only contains the AutoFac package, but it's also going to provide what's known as an Dependency Resolver implementation that will work with system.web.mvc. So it will work with the MVC5 framework. So although the MVC5 framework doesn't come with a container, it provides the right abstractions and the right hooks. So it's very easy to place a container in charge of what the MVC5 runtime is doing and what the MVC5 runtime is trying to create. So I'm going to select this package, autofac.mvc5. I'm going to click Install. The NuGet Package Manager will go out and download this package. It's going to install that package into my project. And now in the next clip, what we need to do is add some startup code to configure AutoFac and to plug it into the MVC runtime so that we can get rid of this error message. What we've seen so far in this module is that there's two types of configuration code in this application. The first type of configuration code is configuration code that is in XML. So this is the type of code that's in the web.config file. Here I can place easy configuration settings like the key value pairs that make up my application settings, including my custom message. But there's also configuration as code, and there's lots of examples of that with the MVC5 framework. So registering my routes is something that I do with C# code, not XML. The same with filters and the same with bundles. What we need to do now is configure AutoFac, the container, as well as configure the MVC framework to use AutoFac. And again, that is something I can achieve through code, so I don't have to write XML. What I'm going to do is add another config file here into the app start folder. So let me click add. I want to add a class, and I want the name of this class to follow the spirit of the other files that are in this app start folder. So we will call it containerconfig.cs. So we have bundle config, filter config, route config, and container config. And I'm just going to change the namespace here. Although the convention in .NET and C# is to 99.9% of the time use a namespace that maps to the physical folder structure of your project. So it does make sense for this to be in the namespace app_start. But you'll notice in MVC5 projects, we typically don't use app_start as part of the namespace. We just use odefood.web. So inside of container config, I'm going to remove app_start. We'll just be in the namespace odefood.web with the rest of these config classes. And the idea here is that inside of this class, I'm going to have a method that I invoke from global.asax.cs, just like we do with filter config, route config, and bundle config. The area registration is a little bit different. It's a little bit more magical, but we'll come to that later in the course. Ultimately, what I want to do is say container config, please register the container. And for this particular method call, there's nothing in the MVC framework that I need to pass in. Instead, I just need this method to exist on the class. It doesn't exist yet, but if I place my cursor here and press Control period, I can say that I want to generate the method containerconfig.registerContainer. And now if I come back to my class definition, I have a register container method here. So what I'm going to show you now is essentially the AutoFact API. So all of these different IOC containers, structure map and Ninject and AutoFact, they're all going to have a slightly different API, but the ultimate goal is to tell the container about the different components and abstractions that you have in your project. So what are the services that you want injected into other pieces of software inside of this application? That's what I need to tell the container so the container can successfully resolve dependencies. And when it comes across something like the controller that is asking for iRestaurant data, the container knows what to do. So first, let's use the AutoFact API and create something known as a container builder. So as the name implies, this is something that will build my IOC container. I'm going to use Control period and bring in the AutoFact namespace because, again, this is something that is specific to AutoFact. So the idea of using dependency injection and having an inversion of control container, those are all generic design patterns that are implemented by many different types of libraries, AutoFact being just one of those. So I need to build my container builder, and then I can start telling this builder about the different abstractions that are in my application. The first thing I'm going to do is register my controllers. So this is a convenience method that if I spell it correctly, I should have the ability to bring in the namespace. But if I type this correctly and hit Control period, I can bring in a namespace named AutoFact.integration.mvc because what I'm invoking is a custom extension method specifically designed to integrate MVC5 with AutoFact. So what this is going to do is scan through my project for the different controller types and register those with AutoFact. So AutoFact knows about all the different controllers that I have inside of my application. So the greeting controller and the home controller. All I need to do is tell AutoFact what assembly contains the controllers for my application. So I'm going to use type of MVC application here. So just in case I'm skipping around too much and you're wondering where the heck did MVC application come from, you might remember MVC application was the class that was defined in the code behind file for global.asax. So it's essentially the class that represents this application. This class will be compiled into an assembly, which is the ode2foo.webassembly. And it is this assembly that contains MVC application that I want AutoFact to use. I just need to reference that type and then ask for the assembly property on that type. And now is my opportunity to also tell the container builder about the specific services I have. So I can say, dear builder, I want you to register a type. So in other words, I want you to use a specific type, which is the in-memory restaurant data class. And I'll need to use Control period to bring in that namespace. So remember, that's in the other project. It's in ode2foo.data.services. I want you to know about this type. And in fact, I want you to use this type whenever someone asks for an object that implements iRestaurant data. So this is the syntax in AutoFact to say, please register this type in-memory restaurant data. AutoFact now knows about that type and use that type when someone needs something that implements iRestaurant data. And hopefully you can see where this is going. If you haven't worked with a container or haven't worked with dependency injection before, anywhere in my application, I can now ask for an iRestaurant data, and I can receive whatever type is specified here. And later in the future, if I ever want to change away from using in-memory restaurant data, I only need to make that change once here inside of container config. And furthermore, I can specify a lifetime for an instance of in-memory restaurant data. In other words, there are additional methods here available through AutoFact to tell it that I want to create an instance per HTTP request. In other words, anytime you receive a new request, I want a new instance of my in-memory restaurant data. What we probably want to start with is a single instance or a singleton, because I'm going to have all my restaurant data inside of the same object. And when I start adding restaurants and editing restaurants, I want to have a consistent data source. So I'm just going to specify single instance. Of course, this could never, ever, ever work if we have multiple users, because those multiple users will be editing the same source of restaurant data. That's something that a relational database is designed to do, and that's something we will have later in this course. But for right now, to keep things simple, we will use in-memory restaurant data and we will use it as a singleton. Now, I just need to create my container from this container builder. So if I go to the builder object and I tell it to build the container, I now have something that I can give to the MVC5 framework to tell the framework, whenever you need to resolve dependencies, please use this container. And I can do that by going to a class known as the Dependency Resolver. And this is a class that is defined by the MVC5 framework. So I need to go to Dependency Resolver, and IntelliSense jumped in and was a little bit eager there. But if I hit Control period, Dependency Resolver is in the system.web.mvc namespace. It is a class with a couple static members. One of those members is a method called setResolver, and I need to pass in my AutoFact container as the resolver for this entire application. And I can do that by using a wrapper provided by the AutoFact library, which is the AutoFact Dependency Resolver wrapper. Use that to wrap a container for consumption by the MVC5 framework. So just to summarize what we have done here, we are constructing an AutoFact container by registering all of our controllers as well as our in-memory restaurant data component. So whenever something needs an iRestaurant data, this container should be able to handle that scenario. And then we've set our container as the dependency resolver throughout the running of this MVC5 application. So anywhere the MVC5 uses dependency resolution to inject dependencies, our container can jump into action. Let's do a build on the application and come back to the browser where previously we had an error because the MVC5 framework didn't know how to construct a home controller any longer. But now, with AutoFact doing dependency injection and my inversion of control container, AutoFact can look at the constructor for the controller and say, I know all about iRestaurant data. You told me what to use. Let me pass in a new instance of that object, the service that you told me to construct, and our application is again up and running.